Welcome to the last lecture. I'm so proud of all of you for making it to the end of the course and making it to the last lecture. Today, the very last thing we'll be talking about is graphing lines, and then hopefully this will be a very good introduction for you as you move into college algebra and further into your math journey. So let's start here. I want to go back to dotted paper. Let's start here with talking about kind of parts of a line. We have the, notice that unless you have a vertical line or a horizontal line, so excluding those two cases, you're going to cross at some point the x-axis and the y-axis. And it's very helpful to know that, and you may recall this from geometry if you took it, a line is determined by 2 points. So if you, I'll go back here, if you have 2 points, doesn't matter where, let's say there and there, if you had a ruler or any kind of straight edge, you could definitely do a lot better than me, but you could connect them, and there's exactly one line that goes through those 2 points. It's a very useful fact. And so all we need to determine a line are 2 points. So all we need, if all we need are 2 points, then the most natural 2 points would be where they cross the x and y axis. So one more thing while we're over here. What does it mean for it to cross the x-axis? Well, it means that the y value is 0, right? Because whenever the y value is 0, it's on this line. And so wherever it crosses, wherever y is 0, that's where the x-intercept is. And kind of the opposite here for the y-axis, your y-intercept is going to be where x is 0. So, looking at the line from last time, y equals 2x plus 1. We can find the x-axis by letting y be equal to 0. So if y is 0, or we can find where it crosses the x-axis by letting y be 0, then we get 0 equals 2x plus 1. We can subtract 1 from both sides, and we can divide by 2 and get that x is negative 1/2. And so if we go back here, you can see that. You can see that here's the line, here's negative 1/2, that's where it's cross. And just looking at this while we're here, we would expect the value where it crosses the y-intercept to be 1. Or we expect its y-intercept to be 1. So y-axis is when x is 0. Oh, by the way, I don't even think I mentioned this. This is called the x-intercept. For the y-axis, we're going to let x be 0, so we get y is 2 times 0 plus 1. We get y is 1 as we expected. And this, we calculated the y-intercept. So now we have 2 points, right? Because we have, here is negative 1/2, and the y is 0. There's point 1. Here's point 2, where x is 0 and y is 1. We have 2 points. We have a line. So this entire, this line is determined by these 2 points. Like they're identical. It doesn't matter if you give me the line or if you give me the 2 points. It's the exact same. I can do the exact same things with each. So let's go to my squared paper again. Let me show you how, you should probably already know how to do this, and we kind of already talked about it, but let's talk about it some more. We're going to call this point negative 1. We're going to call this 1. So this is going to be 1, and this is going to be negative 1. Okay, so we have the point negative 1/2, 0, which is going to be right here. Negative 1/2 is the x, 0 is the y. And then we have the point 0, 1. So 0 is the x, 1 is the y. And now if you put your straight edge between those two, we have a line. Hopefully you draw a better line than me, but you have a line. And this line is y equals 2x plus 1. So that's graphing lines. That's really where Lumen ends, but I think we can go just a little bit further in talking about graphing lines. Let's say I have two lines. Yeah, we'll plot them over each other. Y equals 2x plus 1 and y equals, let's do negative 3x plus 1. Okay, we already determined the 2 points we need for this one are 0, 1. Well, I'll actually do this one first. Negative 1/2, 0, and 0, 1. And the 2 points we need to determine this one we need to find. So if we let y be 0, then we get 0 equals negative 3x plus 1. Move negative 1 over to the other side. Divide by negative 3, and you get 1/3 x. So we have our first point, 1/3, 0. And then we can, that's for our x-intercept. Now we need to do our y-intercept. So let x be 0. We get y is going to be negative 3 times 0 plus 1, or just y is 1. So our other point here is 0, 1. So now if we draw that, I'm going to let each one of these little tick marks is going to be 1/6. So 2, 3, there's 1/6, 2, 6, 3, 6, 4, 6, 5, 6, 6, 6. There's 1. And then 1, negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. There's negative 1. Then we get 1, 2, 3, 4, 5, 6. Here is 1, 2, 3, 4, 5, 6. Here is positive 1, and then negative 1 isn't going to matter. So whenever we plug in our points, first we'll do red. We'll do this guy over here. Negative 1/2 is going to be right here. Negative 1/2, 0. And then 0, 1 is here. So let's go ahead and draw in that line. And we have another line, which is 1/3, 0. 1/3 is going to be right here. And then 0. And then we have 0, 1 right here. So if we connect those two lines up, so where do they cross? Where they cross is going to be where the solutions are the same. There's a solution that satisfies both. If you remember a long time ago, I said that whenever we're solving these equations, it's the equivalent of finding where they cross. And so they cross right here at the point 0, 1. Then the solution to this system right here is x equals 0, y equals 1, because that's where they cross. And you'll be doing all kinds of things in college algebra like this, but I just wanted to show you that kind of, I think, the natural conclusion of the course, where we have basically put together everything that we've learned so far into visualizing these functions and representing them in space. So that's it for our Foundations of College Algebra series. If you have any questions, let me know. It has been a pleasure to go through these lectures with you, and I hope that you've learned something and that this will be helpful for you in your